Have you ever wondered how researchers predict trends in the stock market, or how doctors predict patient outcomes after medical procedures? The answer lies in a powerful statistical tool called regression analysis. Regression analysis is a statistical technique used to determine the relationship between a dependent variable, such as a stock price or medical outcome, and one or more independent variables, such as economic indicators or patient characteristics. By analyzing this relationship, researchers can create a mathematical model that predicts future outcomes. The history of regression analysis can be traced back to the early 1800s, when the mathematician Carl Friedrich Gauss developed the method of least squares. However, it wasn't until the early 1900s that regression analysis became widely used in scientific research. There are several types of regression analysis, including linear regression, multiple regression, logistic regression, and polynomial regression. Linear regression is the simplest form, and it involves modeling the relationship between a dependent variable and a single independent variable. Multiple regression involves modeling the relationship between a dependent variable and two or more independent variables. Logistic regression is used when the dependent variable is binary, such as yes or no, and polynomial regression is used when the relationship between the variables is nonlinear. Regression analysis is incredibly important in statistics because it allows researchers to make predictions about future outcomes based on past data. For example, in finance, regression analysis can be used to predict future stock prices based on past market trends. In healthcare, regression analysis can be used to predict patient outcomes based on medical history and other factors. One real-world example of regression analysis can be seen in the field of sports analytics. In baseball, regression analysis is used to predict a player's performance based on past statistics such as batting average, on-base percentage, and slugging percentage. This information can then be used to make decisions about which players to sign, trade, or release. Marketing, regression analysis is used to study consumer behavior and predict how they will respond to different marketing strategies. For example, a company may use regression analysis to predict how changes in price, advertising, or product features will affect sales. Economics, regression analysis is widely used in economics to study the relationships between different variables. For example, regression analysis can be used to study the relationship between GDP and unemployment rates, or the relationship between interest rates and inflation. Environmental science, regression analysis can be used to study the relationships between different environmental variables. For example, researchers can use regression analysis to study the relationship between air pollution and respiratory diseases. Education, regression analysis can be used in education research to study the relationship between different variables and student performance. For example, researchers can use regression analysis to study the relationship between class size and student achievement. Engineering, regression analysis is used in engineering to study the relationship between different variables and product performance. For example, a manufacturer may use regression analysis to study the relationship between product quality and different manufacturing processes. These are just a few examples of how regression analysis is used in real life. As you can see, It is a versatile tool that can be applied in many different fields to make predictions and inform decision-making. So we can conclude that the regression analysis is a powerful statistical tool that has a rich history and is used in a wide range of fields to make predictions about future outcomes. Whether it's predicting stock prices, patient outcomes, or player performance, regression analysis plays a vital role in helping us make informed decisions.